Hey guys, this is Mr. H. Hey, I am going to do this video is basically going to show you how to look at any table and determine if it is linear, exponential, or quadratic. Okay. So I'm going to look at three different tables and I'm going to show you how to determine if it's linear, exponential, or quadratic. Now, the key idea is that you're going to be subtracting the y values from each other. And if the difference is the same for all of the y values, then it's going to be linear. So let me show you that. Now, most people start with on the left of the table or the top of the table. I like to go over to the right and then work backwards. So if I do a negative, let's make this red. I like that. If we do a negative 10 minus a negative 6, we get a negative 4. So that's the difference. So if I do a negative 6 minus a negative 2, I get a negative 4. Now, the fact that these are both the same is promising and basically says that this table is probably linear. So let's keep going. If I go a negative 2 minus 2, I get a negative 4. If I go 2 minus 6, I get a negative 4. If I go 6 minus 10, I get a negative 4. If I go 10 minus 14, I get a negative 4. So the fact that all of the differences are the same number means that this is linear. We just showed that it's linear. Okay, that's what it is. That's all you're doing. You just do differences. If the differences for all of the y values are the same, it's linear. All right. So now let's go to the second one. Now this table here, we're going to do the same thing. Now not going to use a calculator yet. So let's do clear menu 15. So first thing, 32 minus 16 is 16. 16 minus 8 is 8. 8 minus 4 is 4. 4 minus 2 is 2. Now, you can see that the differences are not the same. So if the differences are not the same, we know from doing that, we know that it is not linear. So let's try something else. So now, once you know now, maybe you've already looked at this and you've kind of figured out what the pattern is, but I'm going to show you how you formally do it. Maybe you can see that this is being multiplied by 2, but I'm going to show you, if you don't see that, how you check it. Again, we're going to go over to the right, but this time, instead of subtracting, we're going to do division. So we're going to go 32 divided by 16, and that's 2. And then we're going to do 16 divided by 8, and that's 2. All right, so it looks like this is going up by a multiple factor of 2. If we do 8 divided by 4, that's 2. And then 4 divided by 2 is obviously 2. 2 divided by 1 is 2. And 1 divided by 1/2. So let me show you how you would do that. You would do 1 divided by, and then I'm going to use a step fraction, 1 over 2, and that's also 2. So this one is being multiplied by 2, the same value. All right. So that means if you're multiplying by the same number, that means it's exponential. All right. So this is an exponential function. That's all you're doing. So you start by subtracting. If the differences are not the same, go to division. So you're going to be dividing 32 by 16, 16 by 8, 8 by 4, 4 by 2, 2 by 1, 1 by 1/2. If those numbers are all the same, it's an exponential function. All right. That's the rule. Now, here's the last one. If I look at this table, I'm going to start by doing the difference. So let me get rid of this. So we're going to go menu 15, menu 15. So we're going to do a negative 3 minus a negative 4, and we get 1. And then we're going to do a negative 4 minus a negative 3, and we get a negative 1. So now, as soon as you see this, you know it's not linear, okay? Again, if it's linear, the difference has to be the same for all of the y values. So we already know that. Now, we can do the same thing that we did before. We can do division to see if it's exponential. But if you look at this, I'm just going to do a couple because just to show you, if I do a negative 3 divided by a negative 4, I get 3/4. Now, if I do a negative 4 divided by a negative 3, I get 4/3. So those are not the same, so it can't be exponential. So now I'm going to keep going in this table because I want to show you for quadratics, you have to subtract twice. So let me show you what I mean. So let me keep going with this table. So a negative 3 minus 0 is a negative 3. 0 minus 5 is a negative 5. 5 minus 12 is a negative 7. And 12 minus 21 is a negative 9. So now, one of the things you hopefully will see is that it looks like this is increasing by 2. But let's go. And now what we're going to do is we're going to take these numbers and we're going to do another difference. So we're going to do 1. I'm going to do menu 15. I want to start over. So I'm going to do 1 minus a negative 1. And I get 2. And then I'm going to do a negative 1 minus a negative 3, and I get 2. And then I'm going to do a negative 3 minus a negative 5. I get a positive 2. And then I do a negative 5 minus a negative 7, and I get a positive 2. And then the last one, I do a negative 7 minus a negative 9, and that gives me a positive 2. So now you can see that I did the first difference, and then I took the another difference of those terms, and you can see that this is constant. It's going up by the same number. So now that means it must be quadratic. So if you take the second difference and the numbers are all the same, the second difference, this is the first difference, this is the second difference. So if the second difference is all the same, then you're dealing with a quadratic. If the first difference is all the same, you're dealing with linear. And if neither one of those work, if you divide the ratio, if the ratio is all the same, it's exponential. All right, that's what you're doing. Now, use the calculator. Don't be too proud to use the calculator, but start on the right and go this way. Start on the right and go this way. So we're doing a negative 10 minus a negative 6, a negative 6 minus a negative 2, a negative 2 minus 2, 2 minus 6, 6 minus 10, 10 minus 14. We're going this way. Always start on the left or on the right and then work your way back. Okay. So that's it. I hope this is helpful. I'm going to stop and post it.